Welcome to this presentation on how solar panels work. In this first slide, we will be discussing the introduction of solar panels. Solar panels are a remarkable technology that can convert sunlight into electricity using photovoltaic technology. They are widely used for clean energy production, as they provide a sustainable and cost-effective way of generating electricity. As we continue to explore solar panels in this presentation, we will discover how they can be a valuable source of energy that reduces our dependence on non-renewable energy sources and also has the potential to save money on electricity bills. Additionally, solar panels have a long lifespan and low maintenance costs, making them a sound investment for both residential and commercial use. Thank you for joining us in this presentation, and let's move on to the next slide to learn more about how solar panels work. In this second slide, we will be discussing the process of sunlight absorption by solar panels. When sunlight hits a solar panel, photons from the sunlight are absorbed by semiconductors within the panel. This absorption of photons causes the electrons within the semiconductors to gain energy and start moving, generating a flow of electricity. This process is known as the photovoltaic effect, which is a core technology that enables solar panels to generate electricity. The more sunlight that is absorbed by the solar panel, the more electricity can be generated. As we move through this presentation, we will explore the factors that influence the amount of sunlight absorbed by solar panels and the ways in which this can affect their performance. Thank you for joining us in this presentation, and let's move on to the next slide to learn more about how solar panels work. In this third slide, we will be discussing the basic unit of a solar panel, the photovoltaic cell. A solar panel is made up of many photovoltaic cells that work together to generate electricity. Each cell consists of layers of silicon that have been treated with specific materials to create a positive and negative layer. When photons from sunlight hit the silicon, they excite the electrons in the material, causing them to flow towards the negative layer, generating an electrical current. The photovoltaic cell is a crucial component of the solar panel, as it is responsible for converting sunlight into usable electricity. As we move through this presentation, we will explore the different types of photovoltaic cells and how they impact the performance and efficiency of solar panels. Thank you for joining us in this presentation, and let's move on to the next slide to learn more about how solar panels work. In this fourth slide, we will be discussing the composition of silicon used in solar panels. The silicon used in solar panels is highly purified and is doped with other elements such as boron and phosphorus. This process creates two different types of silicon layers, p-type and n-type. The p-type layer has fewer electrons, while the n-type layer has more electrons. When these layers are combined, it creates a potential difference between them. This potential difference allows the solar panel to generate electricity by creating an electrical field that drives the flow of electrons from the n-type layer to the p-type layer. The doping process is a crucial step in creating the necessary layers of silicon to generate electricity in solar panels. As we move through this presentation, we will explore how the composition of silicon can affect the efficiency and performance of solar panels. Thank you for joining us in this presentation, and let's move on to the next slide to learn more about it. In this fifth slide, we will be discussing the p-n junction in solar panels. The p-type and n-type layers of silicon within a solar panel meet to create a p-n junction. When sunlight hits this junction, electrons in the n-type layer are excited and flow towards the p-type layer. This movement of electrons generates a potential difference between the layers, creating an electrical field that drives the flow of electrons in the solar panel. The p-n junction is a crucial component in the photovoltaic process, as it creates the necessary electrical field to generate electricity. As we move through this presentation, we will explore the ways in which the p-n junction can be optimized for maximum efficiency in solar panels. Thank you for joining us in this presentation, And let's move on to the next slide to learn more about how solar panels work. In this sixth slide, we will be discussing the creation of an electric field in solar panels. The potential difference created by the p-n junction creates an electric field within the solar panel. This electric field helps to separate the electrons and holes generated by the absorption of photons. The electrons move towards the negative electrode, while the holes move towards the positive electrode. This separation of charges generates an electrical current, which can be harnessed to power various devices. The creation of the electric field is a crucial step in the generation of electricity by solar panels. As we move through this presentation, we will explore how the electric field can be optimized to increase the efficiency and performance of solar panels. Thank you for joining us in this presentation, and let's move on to the next slide to learn more about how solar panels work. In this seventh slide, we will be discussing the generation of direct current, DC, by solar panels. Once the electrons are separated and flow towards the negative electrode, they move through an external circuit, generating a DC current. This DC power can be used directly to power devices or stored in batteries for later use. However, most household appliances and the power grid use alternating current, AC, power. Therefore, the DC power generated by solar panels needs to be converted into AC power using an inverter before it can be used. The direct current generation is a crucial step in the process of generating usable electricity from solar panels. As we move through this presentation, we will explore the ways in which direct current generation can be optimized for maximum efficiency in solar panels. Thank you for joining us in this presentation, and let's move on to the next slide to learn more about how solar panels work. In this eighth slide, we will be discussing the solar inverter, which converts DC power generated by solar panels into AC power that can be used by household appliances and the power grid. The inverter is a crucial component of a solar power system, as it ensures that the power generated by solar panels is usable by homes and businesses. Excess power generated by solar panels can also be sold back to the power grid, providing a source of revenue for solar panel owners. In addition to converting DC power to AC power, the solar inverter can also monitor the performance of solar panels, ensuring that they are operating at peak efficiency. The solar inverter is an important piece of technology that enables solar panels to provide clean and sustainable energy to homes and businesses. As we move through this presentation, we will explore the ways in which solar inverters can be optimized for maximum efficiency in solar panels. Thank you for joining us in this presentation, and let's move on. In this ninth slide, we will be discussing the efficiency and output of solar panels. Solar panel efficiency is dependent on various factors, including the type of panel, weather conditions, and orientation. The more efficient a solar panel is, the more electricity it can generate for a given amount of sunlight. The output of solar panels is typically measured in watts or kilowatts, and higher output can result in cost savings for solar panel owners. Solar panel efficiency and output are essential factors in determining the feasibility and profitability of solar power systems. As we move through this presentation, we will explore the ways in which solar panel efficiency and output can be optimized for maximum performance and cost savings. Thank you for joining us in this presentation, and let's move on to the final slide to summarize the key points of how solar panels work. In this slide, we will be discussing the benefits of solar panels. Solar panels are an environmentally friendly energy source that reduces our dependence on non-renewable energy sources. They offer many benefits, including cost savings on electricity bills, long lifespan, and low maintenance costs. Solar panels can also provide a reliable source of energy, even in remote areas where traditional power grids are not available. By generating electricity from sunlight, solar panels can help reduce carbon emissions and combat climate change. Additionally, solar panels can provide a source of revenue for homeowners and businesses through excess power generation and selling back to the power grid. Overall, the benefits of solar panels make them an attractive and sustainable energy solution for homes and businesses alike. Thank you for joining us in this presentation on how solar panels work, and we hope you found this information informative and helpful. Hi, I just wanted to take a moment to say thank you for watching my videos and supporting my channel. Your comments, likes, and shares mean the world to me and inspire me to keep creating content. If you haven't already, please consider subscribing to my channel. By doing so, you'll never miss a video and you'll be helping me reach more people with my message. I promise to continue providing high quality and engaging content that you love, so hit that subscribe button and join our community today. Thanks again for your support, and I will see you in the next video.